Hi everybody. This video that's I'm going to have posted on the classroom later tonight is a review of the class that we just did. It's the really tough bit of information on circles, so I want to have it on the classroom so that if you need to review it, you can do that. I'm posting the worksheet that I gave you for the notes on the classroom, and the definitions, the three theorems of the definitions of the rules will be posted there too. I'm not going to do them on the video because it takes too long of time. I want to just go over problems with you right now. So you can get those definitions from the classroom. I'll have a separate post on that. All right, first theorem for 10-6 talks about when two secants intersect inside a circle in the interior. And the rule that they talk about is that the measure of the angle, in this case x, is half of the sum of the two intercepted arcs. So the x degrees will equal 1/2 84 plus 130 in this case. So the measure of this angle and this angle, because vertical angles are congruent, add the two arc measures and divide by 2. So that'll be 1/2 times 214. That is 107. So this angle is 107 degrees. That's the rule of the first of them. Make sure you're adding and then cut in half. Now, this one right here is similar. It's just got an extra step. So the measure of this angle and this angle will be adding these two arc measures and cutting in half. And when you add 143 and 75, you'll get 218. That means when you do 218 divided by 2, you get 109. 109 is this measure right there. That's not what we're trying to find though. We're trying to find this measure here. And because they're on the same line, they're supplementary, and that they add up to 180. So 180 minus 109 will give us 71. So these are two examples that are from the first theorem that I gave you. Now let's look at the second theorem that we have. Hey guys, can you keep it down please? I've asked. I got freshmen back there who are not helping me out. Alright, second one deals with a tangent and a secant where the tangent and the secant have a common point. They intersect at the point of tangency. And in this case, if this is point R, this is P, and this is Q, the rule of this theorem says this angle that's created by the secant and the tangent is half of that arc measurement. Okay? So, what that example might be is, if this arc measure is 148 degrees, then this angle measurement is 148 divided by 2 and is 74 degrees. Okay, so that measurement is 74 degrees. because that is half of the arc measurement, and this is the angle measurement, okay? So that is how that works. We can flip that around. If this is 74, this is 180 minus 74. It would be 106 degrees. And then what's the measure of this arc? It's 106 times 2 for 212 degrees. Okay, so there's that. That's the second rule that we have. This angle measurement between a secant and a tangent is half of this intercepted arc. Okay, now we'll do the third one. So we have, in this case, two secants that intersect outside the circle. You could also have a secant and a tangent, and the same rule would apply. The rule is this. This angle measurement, if this is 50 degrees for this arc, and this is 102 degrees for that arc, the measure of this arc is 1/2 this minus this. So take this measurement for this arc, subtract this arc measurement, 102 minus 50. It's 1/2 of 52 degrees. Half of 52 is 26. So that means this measurement is 26 degrees. I've given you the two arcs to find the angle. You could find if I've given you this angle, which is 30 degrees, and this arc, which is 50 degrees, what's the measure of this arc? So 30 will equal 1/2 of x minus 50. Multiply both sides by 2, so 60 equals x minus 50. Add 50 to both sides. So that arc measurement is 110 from this. Okay? And that's another example of how to do those. I've given you the assignment that's posted on the classroom. I've given you all the definitions and the theorems that are posted there. This work needs to be done by Wednesday.